Hi everyone, my name is Partyka, and today I'm going to be showing you how to generate Pythagorean triples using the method of Pythagoras. So to start, the law of cosine states that for any triangle, the relationship c squared equals a squared plus b squared minus 2ab cosine c is true, with sides and angles designated a, b, and c as shown. The Pythagorean theorem is the law of cosines in the particular case of right triangles. If we let the right angle be called c and apply the law of cosines, we can see that the equation becomes much simpler. The third term on the right-hand side disappears because the cosine of 90 degrees is 0, and we're left with c squared equals a squared plus b squared. This relationship is true for every right triangle, but there are specific right triangles whose side lengths are what are called Pythagorean triples because they're all integers. I was thinking about right triangles one day and I realized that in many cases, Pythagorean triples can be better understood if we consider the process of squaring integers. To start, it makes sense that multiplying a number by itself is called squaring, because the result is the area of a square with sides that are the length of the number in question. Using this physical model of squaring, we can see that the difference between consecutive integer squares is 2x plus 1. To make a Pythagorean triple, remember that we need two integer squares whose sum is the square of a third integer. If we let x be the first integer side length and x plus 1 be the third integer side length, we can determine that the second side length is the square root of 2x plus 1. To make sure that we are truly finding Pythagorean triples, we need to choose x such that the square root of 2x plus 1 is an integer. We defined x as an integer previously, so 2x plus 1 must be odd. An odd square must be the square of an odd number because it does not have any prime factors of 2, so 2x plus 1 can be the square of any odd positive integer. Let a equals the square root of 2x plus 1 be any odd positive integer that is the length of one leg of a right triangle. We know it is a leg and not the hypotenuse because it's the square. Its square is the difference of the squares of the other sides, not the sum. In other words, a squared equals c squared minus b squared. To state b and c in terms of a, we first rewrite a as the square equals the square root of 2x plus 1 as x equals a squared minus 1 over 2. Then we can get that b equals a squared minus 1 over 2 and c equals a squared plus 1 over 2. This is an easy way to find a Pythagorean triple for any odd integer. The list goes on forever. Enjoy using this trick to impress anyone who's willing to listen to talk about Pythagorean triples. All of the information in this video I came up with on my own while I was folding laundry one day, although explanations of the same method are widely available on the internet, often referred to as the method of Pythagoras, which is used to generate Pythagorean triples. I hope you enjoyed watching and learned something new from this video. Thank you.